Good afternoon. So in this session, we are going to do some topics of OSPF because this is a very big topic. So I'm not going to complete the whole topic in just one session. So yes, it will take more than one session. First of all, what is OSPF? OSPF stands for Open Shortest Path First Routing Protocol. OSPF. This protocol is an example of link state routing protocol. Before this, we did RIP routing protocol. That was the example of distance vector routing protocol. So before moving into the details of OSPF, first we should know that what is the difference between distance vector routing protocol and link state routing protocol. Look, otherwise there are much differences, but in one line what one can say that distance vector routing protocol are easy to configure. Distance vector routing protocol are easy to configure, but they have less features. For example, in RIP, the command was very easy. Router RIP, network 10.0.0.0, network 20.0.0.0, version 2, and that's it. So the commands were very easy, but RIP had the issue of routing loop. So that means RIP had problems, and RIP don't have much features. So we require, for the today's network, we require protocol with much features. And that's with OSPF, it comes up. But the problem with OSPF is this, that OSPF is quite complicated protocol, or you can say there are so many concepts related to OSPF. So that's why even I said it just before, a few minutes before, that it is a very big topic and I'll take more than one session for just OSPF. So let's start. What is OSPF? So let's see what we can do in a 1 hour session. So I hope my screen is visible. Kindly confirm me.
Yes, ma'am.
Okay, yes, thank you. Thank you. So OSPF, Open Shortest Path First. So I have just said RIP or Distance Vector Routing Protocol, they are easy to configure but has less features. And OSPF, that is an example of link state routing protocol. They have much features but with the complicated topics associated with it. Like even if you see from the command, even I'm starting top to down approach. That is, I'm discussing first command and then I'll slowly move a little bit deeper into the concepts. So if you see even at the command is quite lengthy one. That is router OSPF1, network, that is network address, and this is a wildcard mask bits. This is area. Now we will see what are all these things. Router OSPF, this is a syntax, simple, router OSPF. But what is this one? One is the process ID. Process ID. Now, what is the meaning of process ID? Process ID actually, with the help of process ID, we can give multiple instances of OSPF on single router. What does mean multiple instances? That means, for example, I have a big team. I have a big team for just configuring OSPF. I can bifurcate my networks for different teams. For example, I can tell one team, okay, you will take care of the 10 network, and team B or the second team, you will take care of the 20 network. So team A, they can just give themselves a process ID 1 on the router, and the team B, they can give process ID, any other process ID till 6535. They can give any number. So multiple copies, or I can say the correct word is multiple instances of OSPF can be configured on a single router. In simple words, I can configure router OSPF1, network this. Yes, on the same router, I can configure router OSPF2, network 20.0.0.0 with the wildcard mask and area 0. Is it okay, ma'am?
Yes, ma'am.
Yes, ma'am.
Okay, so this is the role of process ID. That means, again, multiple instances of OSPF on single router you can run. Now the question comes, is it required that suppose I have two routers for which I have to configure OSPF routing? Let's take these two routers. So is it required that I should give same process ID here, let's say 1, and I should and then I have to give this process ID 1 here so that they can communicate? And in another way I can say this question like this, that is it required that both routers should have same process ID so that they can communicate? No, it is not required. That means on router 0, I can write router OSPF1, network this, and on router 1, I can give another router OSPF2. So it is not at all required that for communicating, the process ID of both routers should match. This is not at all required. If it matches, then even good. If it doesn't match, then even good. Next word comes network. This is the syntax again. This is the network address 10.0.0.0. That means that, let's say this network address is 10.0.0.0. Fine. /8. Now you know this, that what is the meaning of /8? /8 means the subnet mask is 255.0.0.0. Now, what is the meaning of this wildcard mask bits? That is 0.255.255.255. Many books or many blogs, I should say, they say that this is the reverse of subnet mask. But no, this is not at all the reverse of. This is not the complete definition, I should say, for the wildcard mask. This is not the reverse of subnet mask. Then how to calculate these bits? This is the way to calculate wildcard mask bits. Wildcard mask bits. For example, your subnet mask is /8. That means I can write it in another way, 255.0.0.0. You know this, that's how to write /8, 255.0.0.0. Then how to calculate wildcard mask bits? Just write 255.255.255.255. And subtract the subnet mask from it. I'm again repeating, just write your subnet mask in this way, that is 255 way, and subtract it from all 255s. Fine. When you will subtract it, what you will get? 0.255.255.255. Because it comes out to be like this. So sometimes the students, they themselves get a perception that it is just the opposite of that it is the opposite of subnet mask, but this is not the opposite of subnet mask. Let's say if the subnet mask is a /16 or /19, /19. In /19, the subnet mask would be written as like this, /19. For /19, I will write the subnet mask in this way. That is 255.224.0. Why /19 in this way? /19 bits on in subnet mask means 8 bits on first octet, 8 bits in second octet, that is 8 plus 8, 16. And then 3 bits on in third octet, that is 16 plus 3, that is 19 bits on in subnet mask. And again, we will subtract it from all 255s. When we will subtract it from all 255, the answer would be 0.0.31. Am I right?
Yes, ma'am. 31.255.
Okay. So in case if you have the subnet mask /19, the wildcard mask would be written in this way. Fine. So this is the way that we calculate wildcard mask bits. Now comes area. This is very, very important concept and a difficult one, I think so. Area. What is the meaning of area? Actually, for managing big networks, we divide our area. Like this one. And okay, this whole picture will be clear to you. So just few minutes. Okay, so don't look at this figure first, just listen to me first. Let's say in India, I'm going to start a new telecommunication network. Let's say csc.com, like similar to Reliance, similar to Geo network. If I'm going to start this kind of network, just think, suppose a router fails in Kashmir, or a mobile tower gets smashed, or mobile tower is not working because of any reason. And the router for a particular network in Kashmir is not working. Let's imagine. Do you think that this information, that is a particular network, for example, 10.2.2.2, just I'm taking an example, this 10.2.2.0, this network in Kashmir Valley is not working. Do you think this information should be floated to Karnataka's router? Do you think this information is required for Karnataka's router? No. Why so? Because Karnataka's router is just interested in summarized information. Summarized information, and not at all interested in detailed information that on which networks in Kashmir are working, which networks of Kashmir are not working, and even in other states also. So the whole big network of India, we divide it in zones. And in OSPF, we term it as areas. Let's say this is area 1, and this is area 2, and this is area 3. Fine. So let's say this is Kashmir's area and this is Punjab's area, or this is Northeast area. There are different areas. Now these areas have different routers or networks in them. That means what I'm talking, that there are many routers in an area. In Kashmir, there will be many towers, mobile towers, or obviously these towers are backed up with routers. So there are many routers in one area. Similarly, there are also many routers in other areas also. And these all areas are connected to common area, that is area 0, or the another name for area 0 is backbone area. Now this is a mandatory rule that every area will be connected to area 0. I'm again repeating this line. Every area will be connected to backbone area, that is area 0. Now, how they will be connected? Now the question comes, how they will be connected? They will be connected with one router. Oh, sorry. With one router. One or two routers, I will tell you. These routers will act as ABR, area border router. These routers will be known as area border router. The major work of area border router or area 0, the major work of area border router or area 0 will be to give summarized information of its area to area 0. So every information is not required to pass on. So ABR will not give every information to area 0. Let's say it's this router is not working, this router is not working. ABR will not tell to area 0 that my particular router is not working. It will figure out itself that which other paths are available or which other networks are available. It will tell only summarized information to area 0 router. Similarly, this concept also applies to other areas. One router will act as area border router in every area. And the major work of area border router is to summarize the information. Now the question comes, okay, let's say this is again a one router with which every other routers of other areas are connected. And if I take back my concept to India's example that I was just taking a few minutes back, that routers in Kashmir and routers in Kanyakumari, routers in Northeast, they will exchange their summarized information with each other, but not directly with each other, through main router, or you can say the area 0. Through area 0, they will convey their information. But the question comes, is this the work done within India only? No. We have to connect to the other countries also. We have to convey our information to other routers also that are available in other countries. So who will perform that work? That work will be performed by one router here. And this will be known as ASBR, that is Autonomous System Border Router. Autonomous System Border Router. ASBR, Autonomous System Border Router. Actually, these areas will give information to a router or directly to this router. Mostly they give to one router, and this information is conveyed to ASBR, and ASBR gives information or communicates its information to the next country's router. For example, if I am connected to Chinatel, I don't know that whether there is Chinatel or not. I'm just taking a word from Airtel in India and Chinatel in China. So let's say there is Chinatel. So ASBR will take the information from these areas and will again summarize the information to the next router that is available in another. The word actually is another autonomous system. Now the question comes, what is autonomous system? Now, autonomous system, you can say, actually the word autonomous means, in Hindi, the meaning of autonomous system is swadheen. That means I have my own wish. Autonomous system, autonomous state. We must have listened these words. Newspapers also, that particular state is asking for the autonomous status. So autonomous means, that means it's my wish. Yes, this is a word here. Autonomous system. Autonomous system means, let's say again, I'm taking example that I have started one telecommunication network like Jio or like Airtel. So if I'm running that kind of network, I am an autonomous system. Why the word autonomous system comes? Because I can run any protocol or any routing policy within my autonomous system. This is complete an autonomous system, one autonomous system. So area is the part of autonomous system. Autonomous system, I can use any routing protocol or any routing policy, and I cannot force any other autonomous system. That is, I cannot force Chinatel that you should also use OSPF because I'm using OSPF. No, I cannot tell them. Okay, here the another protocol comes into work. That is a different story, and we will talk upon later on. That is BGP, that is a different story, but I cannot force any other telecommunication company that you have to follow OSPF or RIP because I am following this. So that's why autonomous system is a group of networks that follows or that comes under, generally under one administration. That comes generally under one administration. For example, Jio is a complete one autonomous system, and that comes under Reliance Networks. So that is a complete autonomous system. Tata Telecommunications, that is a different autonomous system. So autonomous system. And when these two autonomous systems, they communicate with each other, they have to work with the protocol titled as or BGP. But that is not the context of our today's session. So that's why I'm not going into much detail, but just for your information that when two different autonomous systems, they would work or they would communicate with each other, they would communicate through BGP protocol. So in an autonomous system, that means what I'm stressing, within an autonomous system, inside autonomous, I can work with any protocol, RIP, OSPF, EIGRP, any protocol I can work in an autonomous system. For this reason, these protocols are also known as interior gateway routing protocols because they work within one autonomous system. BGP is an exterior gateway routing protocol because it doesn't work within an autonomous system. It communicates, or it works when two different autonomous systems are connected. There, the role of BGP comes. So this is also one of the important things, that RIP, OSPF, and EIGRP, they are known as interior gateway routing protocol because they work in one autonomous system. And area is the part of autonomous system. Number of areas can come under one autonomous system. So you can also think like this, that autonomous system is a superset and areas are the subsets. Is it going fine? Please let me know.
Yes, ma'am.
Yes, ma'am.
Any question till now? Any question?
It's fine, ma'am, so far.
Okay, thank you. So now I'm going a little further now. Here I just discussed that these ABRs, they summarize the information. Now the question comes, what is summarization? What is the meaning of summarization? The word is actually root summarization. This is the work done by ABRs and even ASBR, Autonomous System Border Router. Root summarization. Now, what is root summarization? Let's see. I'm taking two routers. Sorry. Wait, actually someone is waiting outside. You know that I have already discussed this in my previous videos, that whenever there are few ports as compared to your requirement, for example, like I was connecting router 6 with this router, but this router didn't have much ports, so that's why the error came that cannot connect to the port. Why so? Because this router doesn't have enough ports. This router just had 2 ports and it has been used by these 2 routers. So when I want to connect the third one, I had to insert more modules here. So just turn it off and add modules NM4E and VIC2T. Why these modules? You can add any other module also, but because with just experiments and my practice, I've noticed these modules are fine enough to work upon. So that's why I always insert NM4E and VIC2T. Otherwise, it's totally up to you that which module you want to take. Now, look. This router 7 is connected to router 3. Fine. Let's say I have a network here 192.168.1.0/24 here for this network. Fine. And similarly, here also 192.168.2.0/24. And here 192.168. I'm assuming there are 15 routers because here I'm not telling you the commands. I'm just discussing the concept of route summarization. So I'm just taking the example that 15 routers are connected here. So I'm assuming here that there are 15 routers are connected. Now look at the scene. If 15 routers are connected to router 7, what would be the routing table of router 7 for router 3? Or what would router 7 advertise to router 3? It will advertise that I am connected to 192.168.1.0. I'm connected to 192.168.2.0, 3.0, 4.0, and up till 15.0 because I'm just assuming that there are 15 routers connected. But don't you think that this is a wastage of routing table, and moreover this is a wastage of bandwidth, that if you are telling the complete list. For example, I ask a kid that what is in your pencil box. It can just tell me that it has one pencil, one eraser, it has one scale, etc. It can give me the whole description, or it can just say I have required stationery. That means that I want to convey one message, that only in one line this router, or only with one network address, this router can tell its information to router 3. Instead of telling the whole description that it is connected to 1.0, 2.0, 3.0 up till 15.0, the router 7 can give only one line and can send it to router 3. But how it will compute? This is the next question. Look, this is 192.168.1.0. Can I write in this way? There 192.168. Just hold on. That it is. Let's say okay, 0.0. I'm giving this in this network. Let's say this is 0.0. Okay, from 0 to 15. Fine. Now, can I write in this way also 192.168.1234567.8.0? Why so? Because this third octet, this is octet. Actually, this single zero represents 8 zeros. So yes, I can represent this 192.168.0.0 like this. I can represent. So can I write in this way also? One 192.168.0 for 192.168.1.0. Can I write in this way also? For 0.0, I can write 8 zeros and dot 0, fine. For 1.0, for this, like this. And for 2.0, I can write in this way also, 192.168. Sorry, ma'am. Any issue, ma'am? Similarly, I can write 192.168.3, sorry, for 192.168.3.0. Yes, I can write in this way. Why so I can write in this way? Because I knew this thing that actually these zeros comes at place 128, 64, 32, 16, 8, 4, 2, 1. So if I write 1 here, that means I'm talking about 1.0. If I'm writing 1 here, that means actually I'm writing for 2.0. And if I'm turning on the 2 and 1 bit, that means I'm writing 3 for 3.0. If I go on further and further for 15 network, I can write that means 4 ones are on. What does this mean? This means that even if I go for 15th network, how many bits are same in all networks? How many bits are same? 8, 8 bits here, 8 bits here, and 4 bits here. I can write in this way also. I can do this way also. If it allows me to draw a line. No, it is not allowing me to draw a line here. But just see that these 8 bits are same in all networks. These 8 bits are same in all networks. And these 4 bits, 4 zeros are same in all bits. Sorry, all networks. For all networks, that means how many bits are same or how many bits are fixed. 8 plus 8 plus 4, 16 plus 4, 20. 20 bits are same. That means instead of writing /24, if I share this information, if this router share this information with router 3, if router 7 share this information with router 3, the router 3 will come to know that from 192.168.0.0 till 192.168.15.0, these networks are connected with router 7. मैं थोड़ा सा यहाँ पे हिंदी में भी बोलना चाहूँगी बिकॉज हमारे साथ एक मेंबर हैं जो इंग्लिश उनके लिए कंफर्टेबल है, सो दैट्स व्हाई आई वाज स्पीकिंग इन इंग्लिश ओनली. बट मैं थोड़ी सी यहाँ पे अपनी बात पूरी रखना चाहूँगी. मैम जस्ट एक्सक्यूज मी फॉर फ्यू मिनट्स कि यहाँ पे क्या है कि जब एक राउटर है वो राउटर 7 राउटर 3 को इंफॉर्मेशन अगर भेजता है 0.0 से लेके 15.0, अब किसी भी ऑर्गेनाइजेशन में कोई एक ऐसा राउटर हो सकता है जो बाकी राउटर्स के साथ, इतने सारे राउटर्स के साथ कनेक्टेड है और यहाँ पे अपनी इंफॉर्मेशन भेज रहा है. अब बजाय मैं अगर मैं अपनी क्लास की बात करूँ, कोई मुझसे पूछे कि आप कौन से ग्रुप को पढ़ाते हो, मैं कहूँ जी मैं उस ग्रुप को पढ़ाती हूँ जिसमें रोल नंबर 13 है, जिसमें 14 है, जिसमें 15 है, जिसमें 16 है. वो कहेंगे मैडम आप सीधा क्यों नहीं बोलते कि आप क्लास 17 ग्रुप को पढ़ा रहे हो ना, 6 ऐसा कोई ग्रुप, मतलब एक पूरी क्लास का नाम क्यों नहीं बोल रहे हैं ना. तो यही बात यहाँ पे है कि बजाय राउटर 7 अपनी अकेली बात कर रहा है, उसके बजाय अगर वो एक लाइन में अपनी बात पूरी राउटर को बोल दे, दूसरे राउटर को बोल दे, तो दिस इज नोन एज रूट समराइजेशन. अब यहाँ पे अगर 0.0 है तो मैं उसको थर्ड ऑक्टेट को पूरे को खोल के लिख सकती हूँ, थर्ड ऑक्टेट को, ठीक है, 0.0 को वो रिप्रेजेंट करता है. अब ये देखिए एक्चुअली क्या है कि सारे जीरोज हैं, ये 0.0, लेकिन अगर मुझे 1 करना है, 1.0 को रिप्रेजेंट करना है, तो मैं जस्ट इसके लास्ट बिट ऑन कर दूंगी ना, ये वाली अगर मैं बोलूं तो लास्ट 1 पे ऑन है. अगर मुझे 2 ऑन करना है तो सिर्फ 2 पे ऑन है. अगर मुझे 3 ऑन करना है तो 2 और 1 ऑन है. और इसी तरह अगर मुझे 15.0 ऑन करना है तो 8 + 4 + 2 + 1 ये चारों बिट्स अगर ऑन करती हूँ तो टोटल क्या बन जाता है 15। यानी अगर मैं पूरे के पूरे नेटवर्क्स में देखूं फिर भी मेरे पास कितने बिट्स सेम चल रही हैं, 8 + 8 + 4। थर्ड ऑक्टेट में 4 बिट्स ऐसी हैं जो सारे नेटवर्क्स में कॉमन है। तो बजाय इसके कि या तो मैं मतलब अगर मैं रूट समराइजेशन नहीं करती, एक कहते हैं इसको वर्ड दैट्स नॉट गुड इनफ, बट कई बुक्स ऐसे लिखते हैं कि अगर मैं चीप समराइजेशन करती तो मैं चीप समराइजेशन सीधी ऐसे कर दूं कि हाँ जी भी चीप समराइजेशन की थर्ड ऑक्टेट में चेंज हो रहा है तो ठीक है ओके। बट आपको नहीं लगता कि ये गलत है? क्योंकि अगर ये गलत नहीं होता, मतलब अगर ये तो अच्छा ये क्या समझता √3, अगर यही चीज चीप समराइजेशन के थ्रू भेजी जाती यानी इस तरीके से भेजी जाती, √3 इससे क्या कंक्लूड करता कि जो राउटर 7 है वो 0.0 से लेके 255.0 या 255 वाले तक सारे नेटवर्क्स के साथ कनेक्टेड है। क्यों? क्योंकि इसने क्या कहा /16। क्योंकि इसने /16 कहा इस वजह से राउटर 3 सोचेगा कि इस जो राउटर 7 है वो 0.0 से लेके 255.0 तक कनेक्टेड है, जबकि वो ऐसा कनेक्टेड है ही नहीं। वो कहां तक कनेक्टेड है? सिर्फ 15.0 तक। सो हम क्या करेंगे इसमें, हम दैट इज कॉल्ड रूट समराइजेशन। एक गुड समराइजेशन क्या करेंगे कि हम इसको खोल के देखेंगे कि अगर ये 1 0 है तो ये 8 zeros ऐसे लिखे, 1 के लिए एक सिंगल 1 किया, 2 के लिए सिर्फ सिंगल यहाँ पे 2 की 1 देखा, कितनी बिट्स फिर भी कॉमन आ रही हैं, दैट इज /20। तो हम बजाय /16 के हम क्या भेजेंगे /20। इज इट ओके? प्लीज मुझे बताइए। प्लीज लेट मी नो अगर ये बात समझ आई आपको।
Yes, ma'am.
एनी क्वेश्चन हियर? Okay, thank you. So this is known as root summarization. So this is the work done by ABR as well as ASBR. Another term here is designated router. Now, what is the meaning of DR or BDR? DR, that is a designated router, and BDR is the backup designated router. DR, what I think DR as a class representative. Class representative, for example, yes, DR, what does DR does? DR take the information from every router. That means DR, you can say like here, this way, yes. DR gives, yes, ABR also can act as DR. There may be one router that can act as DR as well as ABR, depending upon the size of the area, or so that it may be a big load on a single router if it is doing work of DR as well as of ABR. So DR takes the information from all routers. It keeps the database of every router, designated router. Fine. But here the one term should also be clear to you, that what is the difference between routing table and topology table. Many definitions or many concepts are present in OSPF. So we have to deal with all these things. But yes, okay. What is routing table? So let's take an example. For example, next weekend is off. What I know, next weekend is off. Let's say our CN team thinks, I say let's meet somewhere outside. Let's go to Elante Mall. Elante Mall. For a moment, Just forget Gmap. We all have Gmap in our phones. For a moment, forget that. Let's say I invite you all that, okay, please come to the Elante Mall that we will celebrate okay, we'll meet at Elante. Fine, one thing. I'll go from Zirakpur. Sharad sir will come, or will come from Ambala, or another teacher is coming from Yamuna Nagar. They all reach Chandigarh at Elante Mall, but without Google Map. Okay, they don't have Google Map. I'm not taking big example. Okay, they reach Chandigarh, but they don't know how to reach Elante Mall. So what they do, they open a map. In earlier days, which we used to have a map on paper. Now, the Chandigarh map will be same for me. Chandigarh map will be same for the person coming from Yamuna Nagar, or the Chandigarh map will be same for the person coming from Jalandhar. But the route followed would be different. Because if a person is coming from Jalandhar to Chandigarh, or if it is entering in Chandigarh from Jalandhar, and then it will follow a different route. They will follow different route. And I will follow different route because I'm coming from Zirakpur. And another person is coming from Rajpura. They will, he or she will be following different route. So the paper map is the example of topology table here, and the route anyone is following is the example of routing table. So topology table for all routers in one area will be same, but the routing table for every router would be different. Is it okay? Anyone? Okay, so this is the difference between routing table and topology table. Now, what is BDR? BDR is the backup designated router. Backup designated router is, it just keeps the replica or the whole backup of DR. Designated router. Now, actually, work of designated router are much. We will discuss it in our next session also. That what is the role actually played by DR. But DR role is in one line. I can say that it keeps the record that which networks are not working, which network is working. This DR will take the charge of all this information. Now, again, I'm discussing the same point that one router, they can act as area border router as well as DR, but for the management purpose, the telecommunications company, they may keep it separate. One router will act as DR and they will give information to the area border router. So I think this is enough for my today's session. I'm just going to revise what I have discussed today. So I have started my lecture with the command of OSPF, that is router OSPF-1. One is the process ID. What is the meaning of process ID? That means I can keep multiple copies of OSPF on single router. That is, I can write router OSPF-1 network this, router OSPF-2 network 20.0.0, router OSPF-3 network 30.0.0. So I can keep multiple instances or multiple copies of OSPF on single router. Then I discuss what is the meaning of wildcard mask bit. Now the question might come to your mind that what is the difference between actually what is the role of wildcard mask bit? Seriously saying, there's no difference between wildcard mask and subnet mask. There's exactly what I think. There's no difference. So yes, there's no difference. So wildcard mask, that how to calculate wildcard mask bits, that I think I have erased that information. For example, if you have /8 here, oh yeah, I have seriously deleted that information. If you have /8 subnet mask, so you will just write in this way 255.0 dot 0 dot 0 and subtract it from all 255. So whatever this answer would be, that would be your wildcard mask bit. It is not that some people say in this way that wherever the 255, just give 0 there, and wherever the 0 there in subnet mask, just give 255 there. That would be the wildcard mask made. That means the opposite of subnet mask. That is not true. Just subtract it from all 255s. For example, if your subnet mask is /9, that means 255.128.0.0. In that case, your subnet, wildcard mask would be 0. Can anyone would help me in subtracting 128 from 255? No one is there.
127. Ma'am, 127.
Thank you, ma'am. So this would be the wildcard mask bit if your subnet mask is /9. So this would be the wildcard mask bit. So area 0, here I came with this concept that area 0, when you have to manage a big country network or big network like Airtel or like Geo does, they divide their areas, they divide their whole area, whole country into areas. And these areas are further, they have their multiple routers within them. These routers, they don't communicate directly with each other. They communicate to the DR, that is designated router. And these DR give information to every other router. You can say in this way that DR act as a center point for all routers. They don't communicate with each other directly. They communicate through DR. But this here I have also discussed what is area border router. The role of area border router is to summarize the information within an area and convey this information to area 0's router. And area 0's router, one router is known as ASBR, Autonomous System Border Router, and that router is connected to the another autonomous system, I should say here. Sorry, different autonomous system. But when you connect, what is autonomous system? Autonomous system means group of networks that are usually owned by single administration. For example, Reliance, for example, Tata, telecommunications, these are autonomous system. Why the word autonomous system? Because they can use any protocol from RIP, OSPF and EIGRP within their autonomous system. But whenever their autonomous system have to connect with another autonomous system, then BGP will come into play. Now, how does they do route summarization? That you have to elaborate that how many bits are still common in every network. Then you can do the correct route summarization. That was all for my today's OSPF session. I hope you enjoyed.
Vidhu